Welcome back. We're in lesson 63. We're going to talk about the product of square roots rule. And the product of, actually it should be a P. The product of square roots rule is this. If you have any non-negative numbers, so positive numbers, if you have m times n, then you can separate it into m times n. Okay? So what that means, that's your example. What that means is if you have, let's say, the square root of 20, then we can write that as factors of square root of 4 times 5, so that'd be our m times n, which can be written as square root of 4 times the square root of 5. Okay? So then we can look at these factors and we can pull out any squares. We know that 4 is a perfect square, and it's a perfect square of the number 2. So we can actually say that this is 2 times the square root of 5. 5 is a prime number. It is not a perfect square. We cannot solve it without using a calculator. So therefore, this is as far as we can go with it. All right. Let's say we have another one. Let's say we have the square root of 18. That can be written as factors of 2 times 9, which can be written as the square root of 2 times the square root of 9. We know that the square root of 9 is 3, because 3 times 3 is 9. So we can say 3 times the square root of 2 is the same thing as the square root of 18. Okay, so you see how that works. Step 1, we factor. Factor what's under the radical, okay? Factor the radical. All right, and then we pull out squares from the factors. And then we leave whatever's left or remaining in the radical. And just for clarification, this sign is a radical. It's the square root symbol. That's what we call the radical. All right, so factor the radical, pull out squares from the factors. Like in this case, we pulled out 9 and we pulled out 4. All right, square root of 9 is 3. You can't take the square root of 2. It's not a square. It's not a perfect square, so we just leave it alone. And when we have these types of situations, what we do is we treat these like a variable. We just treat it like a base, okay? We understand what it is, but we don't do anything with it. We just leave it. It's like it's a factor. If we were to get the square root of 2, it'd be a non-repeating, non-terminating decimal. It's easier to write it this way than it is to try to write that big long decimal. So we just leave it. We leave it just like that because it's more succinct and easier to write in that manner. So that is how we will do that. All right, so let's try a practice problem. If you haven't written this down, pause and do so. I'm going to clear the page. So practice problem number 63.1. We are going to simplify the square root of 50. All right, so we can rewrite that. We could say that the square root of 50 is the same as 5 times 10, right? Okay, so we can take this a little bit further. 10 has factors. 10 is 5 times 2, right? So we can write this as the square root of 5 times the square root of 5 times the square root of 2. Well, guess what? The square root of 5 and the square root of 5 multiplied against each other is going to give you 5. So we can rewrite this as 5 times the square root of 2. Because the other thing we could have done here is we could have said 25 times 2, right? We could have easily done as factors 25 times 2, which would have been the square root of 25 times the square root of 2, and we know that the perfect square, 25, is 5. You would have the same answer. So if you do it down to prime factorization, whenever you get two square roots that are the same, then they equal the whole number. So that's something to remember. Identical square roots multiplied against each other, or multiplied by each other, equals the whole number in the radical. Let me give you an example of why that's true. If I were to say the square root of 4 times the square root of 4, I could say that equals 4. These are perfect squares. Square root of 4 is 2. Square root of 4 is 2. 2 times 2 equals 4. Right? Okay. The other thing that we know is if I were to say the square root of 3, right? I could take the square root of 3, whatever that answer is, and multiply it times the other square root of 3. The answer would still be 3. It's like it, because the square root is whatever number, we don't know what that is, but x times x, whatever the number is, would be 3, right? So this number right here, x times x is equal to 3. Same thing here, x times x is equal to 3, right? That has to be the response that we have. That has to be. So whatever that is, we get 1x here, and we get 1x here. We pull it out. X times x is going to be equal to whatever the number is. And in this case, it's 3. Okay? All right. Just remember, identical square roots multiplied by each other, like square root of 4 times the square root of 4, is equal to the whole number inside of this radical. That is the way it works, and that's the way we're going to do our problems. Okay? Sorry about that. Let's do 63.2. We are going to simplify the square root of 200. So let's break it down. Okay, so we have 2 times 100 for sure. And 100 is just 10 times 10, right? So we could also say the square root of 2 times the square root of 10 times the square root of 10. We have a pair. We could pull those out and say 10 times the square root of 2. Because we know that we can't pull anything out of 2, so that's as far as we can go with that. Let's do 63.3. We are going to simplify the square root of 147. All right, the square root of 147 is 3 times 49. 49 is 7 times 7. That's going to be the same thing as the square root of 3 times the square root of 7 times the square root of 7. Well, the square root of 7 times the square root of 7, That's equal to 7. And we have the square root of 3 remaining. That's our answer. We have one more. We have 63.4. We're going to simplify the square root of 108. So we have, let's see, we know that it is going to be 2 times 54. 54 is 2 times 27. 27 is 3 times 9, and 9 is 3 times 3, right? So that equals the square root of 2 times the square root of 2 times the square root of 3 times the square root of 3 times the square root of 3. So we have a pair of 2's, we have a pair of 3's. So that's 2 times 3, that's 6, and we have 1 square root of 3 left. And that's our final answer. All right. So let's look at repeating decimals. When we have a repeating decimal, we have a certain way that we write it. So if I were to say, like for instance, 1/3, if I were to take my calculator and divide that, I would say 1 divided by 3 equals, and it is a non-terminating decimal. It repeats and repeats and repeats, okay? It's still a rational number because it repeats, but it is non-terminating. Which is why in algebra it is so much easier to write 1/3 as a fraction as opposed to trying to write this. This is just, it is exactly this, but neater. And you can wrap your head around that. 1 out of 3. That's so much easier to write and say as opposed to 0.3333 millionths, 300 and whatever thousandths. It's just easier to say. 1/3 is just easier to say than all of this. This is why we prefer to use this in algebra. All right, so when we have a repeating decimal like that, what we typically do is we put a line over the top of whatever digits are repeating. Now, in Jupiter Ed, that's not going to be an easy fix. The only symbol that they have that will allow you to do that is the line symbol. So what I will allow you to do is to just stop at the repeating decimal. So if I ask you to round something or to write it as a repeating decimal, what I'm going to want you to do, if I don't have the line symbol available for you to do it, just write it like this. Just write the repeating decimal again and leave it. And I'll take that. I'll understand that that's a repeating decimal. If the line symbol is available, if I'm able to add it, then I want you to click it and then put the 3 under it, right? Or whatever numbers are repeating. Sometimes it's one number, sometimes it's a pattern of 2 or 3 digits that are repeating constantly. So for instance, if you had 0.423232323, you would write this as 0.423, and the 2 and the 3 would have the line over the top because these are the 2 digits that keep repeating. If you were to have a number that said 0.31879, 31879, you would write that as 0.31879, and all of that would have a line over it because the whole thing repeats over and over again. Okay, so that is how that works. Whatever numbers keep repeating in this decimal pattern, that is what you draw a line over the top of, and that's how it works. All right, so let's look at 1/6. Okay, if I have 1/6, right, let's pull up my calculator. and I say 1 divided by 6 is equal to 0.1666666. And this 7, that's not a 7. It's when you have this is a 6, it just can't write all those numbers. So it rounds it up, right? It rounds this 6 here up to a 7. It takes all of these and puts them up. So 1/6 would be equal to 0.16, repeating the 6. And that would be your answer. Let's look at 1/9. If you had 1/9, you would write it as 1 divided by 9 is equal to 0.11111 forever, right? So you would write it as 0.1 with the 1 repeating. I hope you're getting the kind of the hint and the idea. The line over the top of the integers is what is going to indicate what is going to be repeated. All right, and that's all we have for lesson 63. I'll see you in lesson 64.